Okay, this is power meter. This is P1505TD DC power supply. This DC power supply is generally only a single range, but this is a double range. You can see that there are data displayed here. There are pointers on it. The customary use of different repairs. You can see that there are two lines. This is from a line of voltage output. As you can see, red is connected to red and black is connected to black. This is the power cord, the other end of the power cord. It is a connector, which is equivalent to some flat cables. It is connected to the motherboard's battery connector. Analog battery provides power to the motherboard. The main job of the DC power supply is to provide a stable voltage for this motherboard. Then it has an A below it, and there is also an A here. These numbers, it is the display current data about whether the motherboard is working properly. You can see that there are ranges here. This is the 1 to 5 voltage range. This is the range of 1 to 15 voltage. Here is a range of 1A to 5A. We usually set it at 0 to 15 voltage. Then this current is 5A. And this one above is voltage. For this voltage, we can adjust it here. The maintenance voltage of our mobile phone motherboard is generally between 4.2 voltage to 4.8 voltage. You can see that this is the button to adjust the output voltage. Long press will display an OCP. This is an overcurrent protection. This is an overvoltage protection. This is on to open, this is off to close. We usually turn on this protection switch, because if at a certain moment its voltage and current are particularly large, it will cause damage to the motherboard. So you must open OCP. Then you can also see that there is a 5 voltage to a USB output interface here. This is a basic introduction to a DC power supply. Here is the power switch. Here it says power. We generally use this type of DC power supply because it is a dual range. The range is relatively reasonable. Okay, this is an introduction about the operation of the DC power supply and the DC power supply. Okay, as you can see, this is a multimeter we often use. This multimeter has two ends and two interfaces. Black connects to black, red connects to red. Just these two ports. Let's test. You can see here, the first one here is voltage. This is the voltage range, the range of measuring the frequency of alternating current. The second is to measure the DC gear. This is a function to wake up, make a choice. You can see these two, only one symbol. but here are two symbols. We can use this to select a button of this function. You can see that the unit symbol above is different. And this is a function of turning on the backlight. Then there is a thermometer and this OC here. It measures temperature. And then some other symbols, such as this here for measuring alternating current. The middle one is a year we often use. In this year, measure the value of the capacitors, resistance, diode, and buzzer year. If you see this first, it measures resistance. You can see that this is a unit symbol for resistance. Let's click again. It is a buzzer year. Buzzer year means that when we are connected, it will make a sound. It proves that there is a line connected between the 2 points on the motherboard. They are on the same line, and this line is not disconnected. This is no open line without open circuit. If it is well connected, it will make such a sound. It proves that it is detected the connection and disconnection of the line. We continue to choose. This is a symbol for a year of diode. We generally say that resistance, the unit of the resistance of this diode, is like this. We generally measure the continuity of this line. For example, if these 2 points are connected, it will display 0.002, 0.001. This means that the 2 lines are connected, which means that this line is short circuit. If measuring 2 points show OL, it's proof that they are open line. Explain that these 2 points are not connected. Prove that the line between these 2 points is broken. We need to find the position of the disconnected chips or capacitor and resistor. We see the next. This is a year of 1 Hz. This Hz and the back is AC. This is AC current. This is also AC current. Generally, we don't need to use it for mobile phone repair. Mobile phone repairs are all DC. We usually use the middle year, this buzzer year. Measure whether the line connection between 2 points is intact, whether the continuity is good. Is the connectivity good? There is also this diode year. This is to measure whether the resistance of this strip is normal. This is the introduction to the multimeter. Next, I will explain the microscope. This is a trinocular microscope. We are using a RL M3T microscope. Everyone sees a camera above. It shows what we see through the eyepiece on the display. Let me tell you about the buttons of this microscope. First, this is the left eyepiece. This is the right eyepiece. Below the eyepiece is a knob that can be adjusted. These 2 pieces are adjusted according to the different eye distance. Then the following is the button to zoom in. As you can see it, such as adjustment now, Let's take this chip as an example. Now it is the clearest adjustment. Now everyone can see. Then if we want to see bigger, we need to adjust these two. These two are multiple adjustment buttons. When the adjustment is very large, let's adjust this below. This is focusing. We need to focus. It becomes clearer and clearer. It is obvious that this chip will be enlarged many times. All the numbers above will be displayed clearly. This is a focus button. The bottom is where we place the motherboard. Next, I will explain to you the use of this microscope and step of adjustment. First of all, you need to adjust the height to a position that fits your eye. Then put this motherboard under the microscope for testing. Then turn on the LED. If it is turning off, the light is not very clear. When we open it, we can see very clearly, because the focus of microscope has higher requirements for light. So we try to use this light source. The second step is to close one eye and check with the other eye. Then we use this focusing knob. Adjust the position that the left eye can see to the clearest position. Then close your left eye and use your right eye to observe. And also adjust the adjustment knob of the eyepiece on the right. Then adjust to the clearest time. Use this again. Open your eye and hold these two eyepiece tubes. Adjust their distance to the most suitable. What is the most appropriate one? We need to adjust it to when we look at it. The picture has no ghosting. This is the most suitable. Everyone is different. This needs adjustment. Then we can adjust the size and zoom of the screen through this magnification. Remember to finish adjusting this magnifying knob. Also adjust the focus knob. Will focus accurate and clear. This is the basic introduction of our microscope.